All right, guys. So I've gotten a few questions already in office hours from a few questions in chapter 3. Does anyone else have any questions from chapter 3? You guys are all trying chapter 3 homework, right? Are you guys all in there? It would be a really good idea. All right. We have discussed, we finished 3.1. We worked most of the way through 3.2. I want to come back to 3.2 and finish out a couple things. Let me see, page 302. That seems about right for section 3.2. Sweet. This is one, I don't know, they have a fascination with snow cones, so just deal with that. Whoever the author is, there's something about that in their childhood. I don't know. I'm gonna try to psychoanalyze a math textbook author. Probably not a good idea. So we looked at this problem yesterday, right? More snow cones. Of course, I've got this on the wrong monitor, so give me a minute. Let me throw you guys over here, throw my book over there, bam, and do this again. There we go, okay. So we discussed this line, we talked about the intercepts, we talked about what they meant, you know, in the real world. I want to figure out this one. Look at number 3. Find the slope of the line and explain what it means. I can't remember. I don't think we did that last time. I don't remember. I don't think we did. You can correct me if I'm wrong. I'll accept a correction. But can you guys take a minute, figure out what this is? The slope of this line. I'm pretty sure we might have. I can't remember now.
We actually did do it.
Yeah, we did. In fact, we got all the way to the, this is coming back to me now. We got all the way to the equation of this line, didn't we? I'm pretty sure. Okay. So last time, I believe we got to the point, come here, you write this down next to the graph. Y equals, oh, I'm still in beautiful brown. I love it. 0.63, I believe, is what we got for the slope. Minus 245 is the adjustment. That's how much I got to take off. So this is how much profit per cone, but then it's minus the 245. And the point I try to make is, so this is where you get the general equation of a line. It just kind of comes from what we do naturally. So this is going to be the slope times whatever x means in general, right? In this case, it means number of snow cones. Plus, I know it's a minus sign, but that just means this is negative. The y-intercept. The y piece, I should say. The y piece. Why do I have to say that? Because a y-intercept is a point. It's got 2 parts. So the b is actually the y piece of the y-intercept. I like it. I like it. Okay, okay. So let's try this. I'm going to clear this. Go away, you go away. Try again. Go away. There it goes. This is going to be exciting, kids. Let me try to do this. I'm going to draw my own little graph. This has nothing to do with these problems. I just need some room. Give me some room. Everybody hold on to your hats. Let's see what happens here. Fantastic scale, Jeff. Really some good shit. So let's say I've got this happening. And now I'm going to get some help from my straight line machine. All right. Okay, that's pretty good, Jeff. Good job, buddy. And then I can make a little arrow. Choo, choo. Crap, I missed. All right, screw it. All right. So guys, take a minute, figure out. Okay, Jeff, you got to, sorry, hold on. Sorry. I'm still on straight line mode. Figure out the y-intercept and the x-intercept. By the way, this is just the regular one scale, right? That's all you got to know. You always have to know what the scale is, or else you can't do anything. Figure out the intercepts and figure out the slope.
What happened to your
I have
screen?
no idea. I was gone for a minute. Did that happen yesterday?
Yes.
All right. And my Wi-Fi is perfectly fine, so I have no idea. Let me see. I'm so happy you're all still there. Oh, please, vaccine. Okay. So let me come back to this. I got to redo this. Everything disappeared when I disappeared. That's fantastic. All right, let me talk. Oh, man. Why did you have to wait until I had finished drawing this thing? I swear to God, help me. All right, so let me do it even better this time. All right, now let's see if I can remember what I did here. Okay. So if I have I think it was there and there. Yes. All right. So find the intercepts. Please zoom. Don't kick me out. Intercepts. And the slope. If I could just spell, it'd be so much easier. Hey, when that happened, was I still like here? Was I frozen or something? Or did I just disappear? I was just frozen.
It just disappeared.
I disappeared. Okay. All right.
Chris Angel does.
Dude, it's even better than Chris Angel. I forgot to look this up. Oh, well, I don't know what that is. I'm pretty sure it should be Shutterstock, maybe, instead of Shutterstock. Yeah. Anyway, all right, that's really weird. So let me ask you guys, what's the y-intercept?
0.4.
Yes. So the y-intercept is 0, 4. And the x-intercept?
2, 0.
2, 0. Kick ass. And the slope, you can actually just count it. Remember, slope is rise over run. And you can use the equation, but I don't really need to here. I could just look at it. How much from this point to this point to this point, how much do I rise? I actually don't rise. I fall. How much? Fall
4,
4, and then I run
2.
2. I love it. And then you reduce that. So the slope is -2. So the fact that it's negative makes sense. This is decreasing. And it's going in the 2 is just because it's twice as much change in y than it is in x. Okay, I like it. Because remember, slope is fundamentally y's over x's. So now I'll add another problem on here. So pretty cool with those two. I mean, those should be pretty straightforward. If given a graph, you could find these things. Now, what's the equation of this line? What's the M stand for?
-2.
In general, the M is the slope. So the slope is -2. So this will be -2x. And then what's the B?
4.
What's the B stand? Yeah, the B is the Y piece of the y-intercept. Now, we developed equations of lines without even knowing everything I just did, because it only made sense. For every step in the x direction, it goes down 2 in the y direction. And I start at 4. So I start at 4 and I go down 2 steps for every step in the x. I mean, we put things together through this homework in that way, but now we can do it a little more directly. We can just identify key things, the y piece of the y-intercept, the slope, and then I put them together into the equation. All right. All right. So this book does I think this book does a decent job of showing you the behind the scenes of what all this stuff means. But then once we get past that, we could just go directly to the equation from a graph. All right, so I'm going to clear all this stuff away. All right, stuff. Okay. Blah, 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 blah. Blah, 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 blah. Nah, screw this. All right, what I want to do now is I want to go here. Hold on. Let me see what page this is again. Holy crap, this is a long chapter. Here we go, perfect. Page 445. Dudular. Sweet, I love this problem. So take a minute. This is page 445. If you got your own book, take a minute and look this over. So I want you to realize something. Why do you have to be careful about just looking at the graphs and comparing? Is each graph fundamentally the same, or is there a difference between the graphs? And I don't even mean the lines. I mean just the setup of the graphs. Is there a difference? Do you guys?
Yes.
So what would that difference be? Yes. What's the difference?
Hours, time.
Yeah, this is going by 4 hours and this is going by 5 hours. So that's something to notice. So I can't necessarily trust just looking at the line because the scales are different. So in order to figure out which car is moving faster, what would I have to figure out?
Time minus distance.
No, I couldn't even do that because that would be hours minus miles. That doesn't really, I can't
Or
put
see
those
how
together.
from time to distance, like the one's
Say
4
again?
hours, 100 miles. Like number one is 4 hours to 200 miles, and the second one's 5 hours. To
Good,
200.
good. So what are you actually talking about, this finding about the line? You're going to find the
I don't know.
slope. Yeah, there you go. You got it. And what would the units of the slope be? What goes on the top of the slope? The y's. And what goes on the bottom of the slope? The x's. right? Is that all right? No? Yes? So what would the units be? Y's are in what units?
Distance over time.
Miles. I like it. And then X's are in hours. So that'll be miles per hour. So if you just figure out the slope of each line, you'll know how fast they're going. So I want you to realize that if I plot distance versus time, the slope is the speed, because what is speed? It's a rate of change of distance per time. But that's exactly what the hell the slope tells me. The slope tells me how much is the distance change over some given amount of time. So take a minute, figure out the slopes for each car. Don't say anything out loud. Figure out slope for car 1 and slope for car 2. So I think Tanya got this one started for car 1. What's the slope for car 1? How would you figure it out? You could actually use any point you want to, but I'd rather just start here. How much does it rise and how much does it run?
200 miles 4 hours.
I love it. 200 miles every 4 hours, which reduces to be
I have. Well,
no.
wait, 200
Fif-
miles. 50 over.
I like it. 50 mile an hour. And this guy goes 200 miles in
Now, 5 hours.
5 hours. So he's going to go a little slower. He's going 40 mile an hour. There we go. So obviously car 1 is moving faster. All right, cool.
Kind
I
of
like
look at that.
Yeah, if the scales were the same, I could trust what I see. But something to notice is car 1 well, actually you could tell right away, to be honest. I didn't even realize. I was hoping they would make this a little more suspenseful. Car 1 went further in less time, so you could pretty much tell right away, but oh well, too bad for me. I wanted them to make it a little more suspenseful. So there's that connection between what a slope means physically and what it looks like graphically, mathematically, right? So there's that connection I keep trying to make. I'm going to clear all this away. Go away. Okay. All right, I like this one. Well, yeah, this is, well, okay, this will be fine. Try this one out. These two, number 2 and number 3. Okay, so let's see. X-intercept. So what's the x-intercept?
$50.
Yeah, I love it. So I don't go up and down at all. I just go right 50. So right 50, not up and down at all. Now somebody else tell me, what the hell does that mean?
It's the break-even point.
Yeah, I like it. And you don't have to use that language. We were talking earlier about we're not really business people, but you don't have to use that language, but that's a good thing to know. It is the break-even point. It's how many units I have to sell just to make it up to zero profit, which is better than being over here, of course. Right? But it's still not great to have zero profit. Right? Shareholders won't like that too much. What about the y-intercept?
Zero, negative 200.
Yeah, I don't go left or right at all. I just go down to 100. And now somebody else tell me what that means.
Overhead.
Costs.
It's overhead, and if you don't want to use the language, you could just say if they sold nothing, they would lose $200. They would be out $200, right? So you can say it either way, overhead, or if they sold nothing, no widgets, 0 units, they're out $200. Is it $200? Yeah, this would be more interesting if it was in millions, but it's not. No, to it. It's my little, yeah, it's my little lemonade stand. Why not? Maybe it's a limeade stand. There we go. We'll make it a little more interesting. All right, I'm going to clear all this. So this, I'm hoping that that's relatively simple at this point, right? Finding those intercepts, but not just that, but interpreting what they mean. Okay, that's enough. Let me see. Trying to see how much more I could squeeze out of that. I'm sorry. I just stealthily took it all away. Hopefully everybody was ready for that. Yeah, let's do that too. Why not? Let me put back up here. I wanted to make sure that they actually asked these questions. So let me put it back up here. The y-intercept was 0, negative 200. Can you guys figure out the slope? And then the equation of the line. Jeff, I don't know. Someday I'll learn how to write. All right. So how did somebody that I haven't heard from yet, how did you figure out the slope? Anybody? Anybody else? Can you identify 2 points on the line that you know for sure? I know this for sure, and I know this for sure. So how much do I rise and how much do I run? How much do I rise?
100
You rise 200,
And I run
50.
50. I like it. So if I reduce that, I'll get 4.
Or
What's that mean? They don't give me anything. So I'm going to say profit is in dollars. And then it's the number of units. So it'll be $4 per unit. I like it. Is that all right, everybody? You guys good? So mathematically, the slope is 4. But I'm going to also ask you for units. And it's pretty much always, since slope is y over x, it's going to be these units over these units. That's what it's always going to be. So now I can put together these two things. I know the slope, and I know the y-intercept. So what is this piece? What letter is that piece?
B.
B. And of course, this is
M.
M. So now I can just piece it together. So my profit equals 4x plus B. B is negative, so minus 200. Kabam. Now, how can I check that? Well, if I were to plug a 50 in for X, what should my output be?
0.
0. I should have a 0 profit. And sure enough, if I plug 50 in for X, oh my God, Jeff, come on. There we go, buddy. I get 200 minus 200, 0. Yay, check. So when you have a graph and you find an equation of the line, you can check it. You can make sure that it actually gives you the outputs the line does. So this is what the line looks like algebraically. This is what the line looks like graphically. They have to agree with each other. Okay, cool. I like it. All right. I'm going to clear all this. Go away. Okay, so I think, yeah, it doesn't do much more than that. All right, and that gets a little too far from where we've gotten so far. So I want to come back to, what page was it? We're going to get a little bit into section 3.3. And of course, we start off by looking at, oh, we already did that, didn't we? No, we didn't. All right, so let's see, page 310. Let's get a little bit of your homework done. Why not? So look at this problem here. Hold on. Crappity doodah. Get over here. Yeah, that's a yummy looking problem. I like that problem. So evaluate the expression for the given value. So can you guys do that? Figure out what C is when X is 12. Obviously, you can use your calculator. That's fine. Calculator. All right. So this is very much a basic skill. So this is like the real like foundations of algebra, just being able to plug a value in for a variable. So this is 0.9 times X, but I know that X is 12. Notice how I put parentheses there to preserve the fact that this is times. So when you do this, I think you get that, right? And then you add those together and you get, I think you get this. Is that right?
Yes.
All right, I like it. I love you guys. You're doing really good. Right, today's kind of a boring day. I know, just go with me. I want to make sure everybody's on the same playing field. So this is a pretty basic skill. This is like the most fundamental thing in algebra. It's just plugging shit in. I know X is 12. Let me put a 12 where X is. All right, so that's nothing fascinating at all. So I'm sorry, it is boring, but give me a minute. So what we're about to get into in the next section, if I remember correctly, is working more directly with equations. So let me clear all these out. So in the last section, we created an equation of a line. And now we're going to work more directly with equations in general. So let me ask you this. Let me just give you this. Let me see what you guys think. So what is your current view of what it means to solve an equation? Just go away. Go away. Just go away. All right. Solve this equation. Okay. All right, so the whole idea behind solving an equation is trying to get the variable by itself. So if I solve this equation, then what did somebody do? Somebody solve this equation, what did you do exactly?
Added 2 to both sides.
Yeah, so if you add 2 to both sides, the way I look at this is I'm trying to unbury my variable. There's my variable, it's got extra shit. If I could just get it by itself, I would know what x equals. So x is 9. And of course, did I even have to do algebra on this thing? No, if I said, what's the number when I take 2 away, I get 7, you go, 9. You didn't even set up an equation because you know 9 minus 2 is frickin' 7, right? But this is algebra saying, okay, when the equations get freakier, this is the format you could use. So something I like to do, let me see if you guys are cool with this. I'm gonna clear that away. And something I like to do is this. Somebody give me, so we're not answering this question still. Go away question. I don't care about you. Somebody give me a value for x. Anybody? Anybody? Give me a number.
12.
Any number. Say again.
12.
What'd you say? 12. Okay. All right. Now go with me for a minute. You ready? So x is 12. In this problem we're working on, x is just 12. That's what x is. So what is x minus 3?
9.
I like it. So what is twice x minus 3?
15.
No. What's x minus 3?
81.
No.
18.
Say it again.
18.
18. If x minus 3 is 9, isn't twice that 18? So a couple things I want you to realize. Everybody was completely cool with that first thing. And what you did was, I took 3 away from this side, so of course you took 3 away from that side. But did you even think of it that way? No. You're like, the number is 12. So what's the number minus 3? Freaking 9, because 12 minus 3 is 9. Okay. So what's twice what we just did? Well, twice 9 is 18. Okay. Let me stop for a minute. Are you guys? So right now it just feels like we're just doing some really funky, weird, freaking playing with number shit that a math person might do when they're bored. Oh, x is 7, 3x is 21. Oh man, I'm in the DMV. When is it my turn? No. So what I'm doing is solving an equation is doing what we just did backwards. Undoing the shit that somebody did to this poor dude here. If I can get him by himself or herself, I have no idea. I have no idea how to check that. Variables, I don't know. Getting away from the biology of variables. Whatever this thing is, if I can get it by itself, I can identify what it is. Because it will be a statement that says this is this. Okay, then I'll know what the shit is. All right, I am overanalyzing solving equations, because I want you to really get this, in case you never really understood what the purpose of moving shit around was. Is just trying to get my variable by itself. All right, let me clear this away. Let's see what the book does here. Now this is interesting. I kind of like this. So these statements, New York City is the capital of Guatemala. Well, that's interesting. Over 1 million species of animals have been cataloged and named. 8 equals 5, and 13 minus 10 equals 3. So it turns out, obviously, the first statement is false. Second statement, you might have to look up, but yes, over 1 million species of animals have been cataloged. I think there's like over 1 million species of insects. I don't know. 8 does not equal 5, so that's obviously false. All right, so there's an idea about statements being false or true. So I know that in English, but an equation is a mathematical statement. So that's something different. So what we're doing when we're solving an equation, now just go with me, I'm really sorry. I know some of you guys are like, oh my God, I know how to do this shit. Well, that's great, just hang out. When I solve an equation like this, when I solve it and I get an answer, what this really means is, oh my God, Jeff. Sorry. Go away. Okay. What this really means is when this is true, when this is true, then holy crap, this is true. So when this statement is true, then this will be true. That's what it means. All right, I like it. So let me clear that away. That's going to become very important in a bit. I'm going to clear that away. Go away. Okay. Let's see. Blah, 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 blah. Oh, yeah. This is barf. Oh, so let's do this. This is not a bad thing here, number 2. Yeah, and number 3, well, okay, this is getting at an idea. This is a very interesting idea. If I start with the true statement, and I add 1 to both sides, I'll end up with a true statement. If I start with a true statement and I multiply both sides by 2, the statement is still true. So if I start with something like this and I assume it's true, when I add or multiply or subtract or divide both sides by something, the statement is still true. So that kind of comes back to the idea of when this is true, then this is true. All right. Maybe. So that's the point this thing is trying to make. And then it wants you to realize we've actually kind of used this idea before. 1 foot is 12 inches, so therefore 3 feet is 36 inches. And why does that make sense? Because I took the statement 1 foot equals 12 inches, and I just multiplied both sides by 3. So if I have a true statement and I do the same thing to both sides of that statement, the statement is still true. If I have a false statement and I do the same thing to both sides, the statement is still false. All right, we're taking a deep dive here, kids. So let me clear all this away. So let me ask you then, let me throw this at you right now, because they just keep doing the same shit. I'm going to clear this away. It's gone. Now, let's try to solve, get out of here. Stop it. What are you? Why are you there? Oh, I don't care. Let me ask you this. Let me do one thing with you guys. I don't know why that little square is there. 2x equals x minus 1. Okay, let's see. So this is a little bit different than what we've worked with before. But what is my goal when I'm trying to solve an equation? When do I know I'm done? What's the answer gonna look like? It's gonna be what's going to be here by itself?
A
When I
variable.
get the, yeah, the variable is going to be here and there's going to be a number on that side. That's when I know I'm done. Will I always be able to get there? No. But I know I'm done, and there's an answer when I get x equals numbers. Is that cool? I mean, that's what we did just a minute ago. So what is fundamentally kind of wrong with the way this is right now, considering that's my goal, to have x equals number? What's fundamentally wrong with this equation?
There's X's on both sides and numbers on both sides.
What the shit? There's x's on both sides. What the shit? Sorry. So it kind of makes sense that if my goal is to get like x equals 3 or something, blah, 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 I want all my variables on one side. So what would I do to this side so that this x is just gone?
Subtract x.
Yeah. So if I subtract x here, I've got to subtract x there. So I did the same thing to both sides. So that is numero uno. That's the number one thing to be careful about with equations. Whatever you do to one side, you must do it to the other side. Right? The visual is it's like a scale, right? In fact, have I done my Indiana Jones thing with you guys? Have you guys ever seen Indiana Jones and the Raiders of the Lost Ark? Do you remember the scene when he's got the gold statue at the beginning and then he puts the bag of sand there, right? So I've got to like balance my equations. So he didn't balance his equation correctly. He didn't do the same thing. It wasn't the same weight. Come on, Indy. Take some freaking algebra. So if I take x away from this side, I better take x away from that side. Keep it balanced. So what is 2x minus x? Don't say 2. Don't say 2.
X.
X, right? So if I have 2 x's and I take 1 away, I got 1 x left. And what's on this side? What's left on this side?
-1.
-1. I like it. So let's check this. How do I check this answer? Well, the equation was 2x equals x minus 1. So to check it, when this is true, is that true? So that's why the skill check from the last section involved plugging values in. So if x is -1, how can I rewrite this side? That might be too easy of a question. You're all like, come on, give me a hard one, Jeff. So if x is -1, I just replace that with -1. And on the other side, I replace that with -1. What's twice -1?
-2.
And then what's -1 minus 1?
-2.
Okay, check. So how do you check your solution? You see the answer I got, does it make the equation true? Does it make it work? And if it does, you're golden. All right, let me stop for a minute. Oh yeah, I'm curious. All right, I'm going to give you an equation to try, and then I'm going to make something kind of nifty. We'll see if you guys think it's nifty. I don't know. I'm going to clear that away, and then I want you guys to try this equation real quick. Bam. So solve this one. We're not doing this problem. All right, Jeff, stop doing that. Hold up. Go away, problem. We're not caring about you. So solve this. Solve. What do you got, Jeff? Write in English. There you go, buddy. All right, so solve that equation real quick. And while you guys are doing that, I'm going to set something up. All right, so you guys are probably done with that. Let me see. I'm trying to make something nifty. So what would you do to solve this? What's kind of like in the wrong place? Anybody? What's in the wrong place? Does that make sense what I'm asking?
No.
I'm sorry. So in this equation, when do I know I'm at the end? When on one side there's what, and on the other side there's what?
I subtracted 2x from both
I like it.
sides.
So Nikisha's like, I like Nikisha's thought. She's like, I don't know what the hell this guy's talking about. Let me just say what I did. So real quick, go with me. I know I'm at the end when I have an X on one side and numbers on the other side. So this guy is in the wrong place. He should be with these other X's, right? So I'm going to subtract 2x here, subtract 2x here, so that they cancel here. And then, of course, you get the answer. 3x minus 2x is
X.
x. And on this side, all I have left is 7. So now I know x must have been 7. And if I check it, 3 times 7, does that equal 2 times 7 plus 7? 21 equals 14 plus 7. Check. So that is correct. All right, so everybody do this. You ready? You ready? I'm going to kind of do this live because I couldn't figure out something. Everybody do this with me. So find a piece of paper or somewhere where you can do some work. You guys ready? All right, I want everybody to pick a number. It can be any number and write it down. All right. Now I want you to, has everybody got a number? I want you to add 3 to your number. All right, so we got that. Now I want you to double what you got right now. All right.
In the same problem, Professor?
Yes, so for example, let me kind of do this with you. So I said, what I've got so far is I said, pick a number. So I'm going to pick 11. Then I said, add 3 to that number, right? You guys see? Add 3 to that number. And then I said, double that number. Just stay with me, stay with me. Now subtract twice your original number. So for me, I'm going to subtract 22. You can do it, Jeff. Twice your original number. Subtract twice your original number. If you did it all correctly, you should all end up with the same number I got. So let me say it again. Pick a number. Add 3 to the number. Double what you got. And then subtract twice the original number. What's happening in chat? Let's see. Oh, okay. Doesn't this now, this is a simple version of, I'm sure you guys have heard this shit before. And a more complex version would be like, add the number of pets you got, and then add your birthday, and then subtract 7, and you get 3. Everybody got 3. Holy shit, how did you do it? Right?
Witchcraft.
Exactly. That's basically it. Right, so we're about to go into the Hogwarts portion of our class, which is the math magical portion of our class, right? You're a hairy wizard. No, stop. So no matter what number you pick, you're going to end up with 6. You can try it again. Let's try it again. So pick a number. It doesn't even matter what the number is. Let me pick 100. And then what did I say? Add 3, double it, subtract twice your original, and you end up with 6. So what I want to do now, let me see if you guys can stick with this. This is sort of tangentially related to what we're talking about. Let me erase some of this stuff. Make some room. Get out of there. Give me a minute. I can't get rid of that square. I have no idea what that's doing there. So I appreciate that some of you guys are freaked out by this a little bit. So let me say this. If I wanted to start with the most general number, now listen, so let me start with every number. I'm going to start with X. Is that X represents every number, right? And didn't I just say this is supposed to work for every number? So let me just write every number. There it is. There's every number. So I'm not going to start with 11. I'm not going to start with 100. I'm going to start with X. And then what did I say? I said add 3 to your number. You guys with me? All right. Then I said double your number. And then I said subtract twice the original number. So subtract twice the original. Of course you're going to get 6. I made it so you get 6. Do you guys see that? This is a really great time to bring that up because I know you've all heard this kind of thing before. I know you have. Add your birthday and then subtract how old you are and then you get 11, blah, 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 whatever, right? This is it. This is all this is. So you start with X and you do some shit and you can make the answer come out to whatever you want it to be. If you know how to manipulate things algebraically, right? Which I do. All right, that's enough of that, Jeff. I'm going to clear all that away. Bah, okay. I still can't get rid of that box. I have no idea. What are you doing there? Let me see. Anything else interesting in here? Blah, 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 blah. Blah, blah, blah. Let's go to the group work. Get out of here. I don't care about this stuff. Get out of here. All right. Oh, there's more snow cones. Why? Why are there more snow cones? I don't know. Let me see. Do I want to do this? No. I'm trying to figure out what else do I want to do with you guys here. Well, let's see. This one looks like it might be more interesting. Let's look at the homework. Let's see what the homework is going to look like. So they give us an equation here. Oh, this is a little bit evil, but can somebody look at that equation? It kind of sucks the letters they picked for this equation. Can somebody tell me from this equation what the slope is?
2.6.
Yes, so in general, the equation of now it sucks they picked the letter M to mean miles traveled. But whatever's in front of the variable is the slope. And then the y-intercept, what's the y-intercept going to be? Somebody else.
5.1.
Yeah, be a little more careful. So B is 5.1. So what's the y-intercept? I love it. You're probably like, what the hell does this guy want from me? It's 2 parts to it, right? It's going to be 0, 5.1. Become a point. Rawr. All right. Is that anything they ask you? I almost don't care. So that's kind of like what we went over in section 3.2. This section is going to be using that equation in different ways. So, you know, I'm not going to do this homework for you. Let's see. So they're going to give you values and you've got to plug it in. So the one I am interested in, let's do number 2, just because you're going to get more practice of this anyway. If you have $18 budgeted, how far can you go? This is a nifty question. So what does M represent in this equation? Let me take away some of my drawings here, guy. What does M represent in that equation?
Miles.
Miles you can go. And what does C represent?
Trip.
The cost of the trip, I like. So if they tell me I've got $18 and I'm going to spend all of it, how far can I go? What can I do with 18? Where would I put it in the equation? What variable does it go in for? It's obviously not a number of miles traveled. It's
C.
money. Yeah, so this is going to go in for C. So I can rewrite, here's the equation. And I can put in place of C, I can put 18. I like it. So now to do this, so this is a little more complicated of an equation, but let me see you guys. Where's my variable that I'm trying to solve for? It's in this term right here, right? You guys, that's obviously where the variable is. So how do I get that by itself? What do I mean by that? How do I get this thing by itself? Why is he not by himself right now? What other shit's on this side that makes him not by himself?
5.1.
5.1, that damn 5.1. So let me get rid of that 5.1. Let me take that line out of there. How do I get rid of that 5.1? What do I have to do to both sides to make him cancel?
Subtract 5.1.
I like it. Let me bring it up here. So 18 minus 5.1 turns out to be 12.9. And then what's left on this other side? If I kill that, that's dead. So I just have this dude, right? Now. Here's the other huge thing about equations, which we already used. When I'm solving equations, it's all about undoing all the shit that's being done to my poor little x. This is kind of like what I have in my head. I'm trying to save x. It's got all this shit happening to it. Let me undo all this shit. I can imagine myself just throwing rocks off of this dude. Get out of here. So here's my m. I'm trying to get my m by itself. What is happening to the poor m?
It's being multiplied by 2.6.
I like it. Now somebody else tell me, how would I undo that? How would I cancel that? M
Divide,
is being, sorry, go ahead.
divide 2.6.
Yeah, so if I divide both sides by 2.6, I always have to make sure that what I'm doing to both sides is actually canceling the shit that I don't want, right? So I can't subtract because subtraction can't kill multiplication. I've got to divide. So I get m by itself, and what the hell is 12.9 divided by 2.6? It's going to be something, I don't know. Something kind of gross, seems like.
6.
What is it?
4.96.
4.96? Okay. So almost 5 miles. We can make it almost 5 miles. That's what that means. So Cabby's going to kick us out. When it's approaching 5, he's going to say, get out of my cab. Okay. So that's how we're going to work with equations of lines more in a more algebraic method. We're going to start using them to solve for one or the other variable, right? So we're going to look at it more as a true equation that we can solve. Okay, I think that's all I want to do for today. That's a pretty good spot to stop. A few of you guys have got 3.1 done. I want more of you guys to work on 3.1, maybe get into 3.2 and come with some questions tomorrow. I mean, not tomorrow. Don't come tomorrow. Monday. On Monday, I promise that I will have the homework sheet updated, and we'll talk about when the next quiz will be. I'm thinking it's going to be Wednesday at the soonest. but we'll talk more about it on Monday. All right, so any questions on that? I still have to work on that. Okay, so I'm gonna go ahead and call it officially. Let me know if you want to stick around, if you have any questions. I'm gonna clear this away. So everybody got what they need from this? Okay, I'm gonna clear it away. Stop sharing. Does anyone have any questions? Anybody need me to hang out for a bit? You guys good? People that are actually here.
Yes, thank you, Professor. Have a good day.
I'll see you guys.
Professor, the
Yes.
snow cones in the book, the people who wrote it, they used to have a snow cone business. It says on a caption next to one of the pictures.
Oh, I'm not very observant. So that explains a lot.
Yeah,
It's
they're
sort of like,
insider knowledge, it would seem.
it's sort of like, what was it in, have you ever seen Arrested Development? There's always money in the banana. I can't remember. Anyway, they had some kind of a banana business.
I haven't seen it, but my brother's seen it. He just laughed from the other side of the room. So,
Oh, okay. There you go. There you go. There's always money in the banana, whatever. I can't remember. It's been a while. All right. Anyway, that's all for me. Thank you for that because I totally missed that. That explains a lot. And I am out of here. I'll see you guys later.
later, Professor.